16, think and discuss. Got two questions from here. First, why does helium release in the atmosphere eventually disappear into space? So we have all sorts of gases in air, and the temperature of the air is related to the average kinetic energy. So let's assume that the argon and the nitrogen and the helium and the oxygen and whatever else, the carbon dioxide, are all have the same basic average kinetic energy. Well, if you think about it, you know the formula, you know it by heart. I'm going to tell it to you anyway, but you should say it along with me. The formula for kinetic energy is 1/2 mv squared. So if the V is roughly the same for all of them, then the bigger the mass, the kinetic energy is the same roughly for all of them, then the bigger that the mass is, the smaller the V squared is. And so therefore, since helium, number 2 on the periodic table, is a relatively light mass compared to a lot of the other things in the air, then it will have a higher speed. And so the faster the speed is, the more apt it is to hit escape velocity or randomly shoot up into the farther into the atmosphere. So helium is more apt to escape. Again, statistically speaking. 92, suppose at a restaurant you are served coffee before you're ready to drink it. In order that to be hottest, do you add cream first or add cream second? This is actually a relatively interesting question, and some people have actually done experimentation on it. So we do have a couple of issues, a couple of things here. And so one of the, I guess the three main things is that the darker an object is, the more more quickly it gains heat and also loses heat. And so by putting cream into to black coffee, you are lightening the color, and therefore it will not lose heat as fast. Now, if it's a hot day, then it won't gain as much heat either, but generally, are you drinking coffee on a hot day? I guess some of you are addicted. Yeah, I can stop anytime. There's also the issue of that if you think about Newton's law of cooling, that it loses temperature, it loses heat faster the greater the temperature difference. By cooling it right away, that you are by cooling it right away, it's not going to lose any remaining as fast. And the other one is that by thickening the liquid, you also are decreasing the rate at which the energy basically dissipates through the coffee, and it's not going to lose as fast. I do want to point out there's an experiment done by the nakedscientists.com. It's https://www.nakedscientists.com/get-naked/experiments/win-add-milk. They actually did the experiment. There's a nice little graph there talking about the temperature, and that even though you get this very fast drop in temperature as soon as you add the milk if you're looking at it, it's the red line. Over the long run, when you add milk later on, it's very clearly that adding the milk first does not, in the end, it is warmer it looks roughly by about 10% warmer. Now, is that significant? I don't know. Don't drink coffee. Don't know how hot you actually want it. But there it is. So hope that is enough, and that's the end of chapter 16. Think and discuss.